Hi everybody, this is Ryan from Junior Pi, and today we're going to go through quite a detailed construction of how to make all the connections on the SparkFun Inventors kit to make our LCD Pong game. We've been fielding some questions on our blog posting with regards to how to do it, and today we're going to show you how. So first of all, the parts, we're going to have 24 jumper wires. So all together here we have 24 jumper wires. We have our redboard and breadboard, our LCD button, our 10K potentiometer, and our piezo element. We then have our 3 LEDs. We're using red, followed by 6 10K resistors and 4 330 ohm resistors. And those are all the parts that we'll be using to build the LCD Pong game. Alright, so let's get started here. Okay, so first things first, we're going to put all the components on. So the first thing we're going to do is we're going to take our LCD. Okay, and so with the pins on the LCD being on the top, all right, what we're going to do is we're going to connect them to look for the H row, H as in Harry, and we're going to connect the LCD to the first 16 pins in the H row. Okay, so I'm going to take my LCD and I'm going to put it like so. So we now have our LCD connected. All right, next we're going to take our button. Now again, the orientation of the button doesn't matter. That being said, the orientation can go one of two ways. So we just want our the contacts on our button going across the breadboard, and we want to connect them. Two of the contacts are going to go to C22 and C24. So I'm going to look for the C row and C22 to C24. Move it over one. And then the other two are going to go across the gap in the breadboard, and they're just going to connect somewhere over here. They're not actually used, but just for support of the button. And there we go, we have the button installed on the breadboard now. Next is the potentiometer, which we use to control the paddle in the Pong game. So first things first is you have to look for the orientation. So you should see a number 1 and a number 3 on the potentiometer. Okay, so holding that as being on the down side or closest to the gap in the middle of the breadboard, we're going to connect that right beside the button. And we're going to connect it into the very last row, which is the E row, okay, in pins 26, 27, and 28. Okay, so again, I'm going to put this in here, so it should look like it's going right beside the button, pretty snug. So my 1 is in this bottom corner, my 3 is in this bottom corner, and my pins are on E, 26, 27, and 28. And that's the installation of the potentiometer. Next we have the piezo element itself. So on the piezo, you'll notice if you flip it over, you should see the positive and negative. We want to make sure that we take the negative terminal or pin, and we want to connect it directly to the negative rail. Okay, so that's the minus sign, that negative rail that goes all the way down here. All of those are connected. And then the positive terminal, we're going to connect that to A, row A, column 18. So I'm going to do that first actually. I'm going to take the positive terminal and connect it to A18, and then the other side is I'm going to have to stretch the terminals open a little bit and connect it to a close negative rail. Okay, so A18 positive and negative rail directly. And there's our piezo element installed. And lastly, for hardware, we have the LEDs. So we're going to take our LEDs, again, cathode, anode. So the negative side is the short leg, positive side, if you want to think of it positive, negative, is the long side. So we're going to make sure the short side of the legs is connected directly to the negative rail on the opposite side. So the negative rail down here is where we're going to be connecting the short leg on the LEDs. Alright, so what we're going to do here is use the second, third, and fourth last holes in the negative rail. Don't use the very last one. We're going to make a connection with the jumper there later on. So I'm going to go one back, and that's where I'm going to connect the negative, so the short side of the LED, and the positive side of the LED is going to go into row J, which is this last row So this row right here is row J and column 30. So right there is where the positive, the long side, is going to go. So long side in J30, short side in the second last negative. Take the next LED, very similar. So the short leg goes in negative. I'm going to put it in the negative right beside the previous one. And the long side, the positive side, is going to go into J28. And lastly, one more time, with our last LED, with the short side, short leg, going directly in the negative rail, and the long side going into J26. So really all we're doing is we're connecting the positive side to the J row and just leaving a column each time. Okay, so J30, J28, and J26. And those are the LEDs installed. So that's it for the major components. The next thing we're going to do is take our 10 resistors and get them set up, and then we'll worry about making the connections with the jumper wires. Okay, so here we go. Again, make sure you're paying attention. We have 6 10K resistors and 4 330 ohm resistors. Make sure you're using the correct one. Okay, so again, resistors don't have polarity, so just like I guess nothing else we've done so far, everything else has polarity to it, I guess minus the button, but unlike the LEDs, resistors don't have polarity, so it doesn't matter which way is which. There's no long and short leg on the resistor. So we already have them pre-bent so they can fit nicely in the breadboard. So we're going to take a 10K resistor and we're going to first wire up the resistors for the LEDs. Okay, so it gets a little tight in here, but just try to follow along. So we're going to connect J29 to H30. So I'm going to look, I'm going to find J29 and H30. Okay, so J29, H30 with a 10K resistor. Next, another 10K resistor, and we're going to connect it to J27 to H28. J27 to H28. You can start seeing the pattern here. Okay, and one more 10K resistor. We're going to connect it to J25 and H26. J25, H26. Okay, there we go. So we have our 10K resistors. Again, polarity doesn't matter which leg is which. And those will be our current limiting resistors for our LEDs. Okay, so continuing on with the LEDs, the next set of LEDs we're going to use is to build the LCD backlight voltage divider. And this is basically just a way of getting the correct voltage into the LCD for the backlight. So it's not too bright, it's not too dim, it's just right. So again, there's 2 resistors we need to use here. So again, pay attention. Don't flip these around. I mean, like put the 330 where the 10K is supposed to go or vice versa. So again, I have our 10K resistor. And what we're going to be doing is connecting the negative rail, okay, to B8. So I'm first going to find B8, so row B, column 8, there, and then over to the negative rail. Again, anywhere convenient in the vicinity there on the negative rail is fine because they're all connected down the negative rail. Next, we're going to take our first 330 ohm resistor. And then what we're going to do is we're going to connect A8, so right beside where we just finished, A8, and we're going to go over and connect that to the positive rail. Okay, so 330 ohm resistor between A8 and the positive rail. Okay, there we go. So there's our simple little voltage divider circuit that we'll use coming up here to provide the correct backlight voltage to the LCD. Next is another voltage divider circuit to provide the correct voltage, which is substantially lower, but it's for the contrast for the LCD, so it's we can see the characters fairly crisp on the screen. So this is we're going to be using one 10K resistor to start, and we're going to be connecting the positive rail to A10. Okay, so A10 to the positive rail with the 10K resistor. And next we're going to use our last 330 ohm resistors. Ultimately, if we had a 1K resistor here, this would this would work in place of these three, but using the components in the Inventor's kit, we don't have any 1K resistors, so we're going to use three 330 ohm resistors in series, which gives us 990 ohms of resistance. Okay, anyway, so what we're going to do is we're going to go from C10, okay, so C10 to A11. So C10 to A11 with the 330 ohm resistor. Next, another 330 ohm resistor, and we're going to be going from C11 to A12. So it's basically the same as the last one, just 2 columns down. Okay, so another 330 ohm resistor, C11 to A12. And lastly, our last 330 ohm resistor that we need to use in this entire project is going to go from B12 to the negative rail. Okay, B12 to the negative rail. So B12 is here to the negative rail is there. Now, real quick, it should be worth mentioning that, again, any of the letters A, B, C, D, E, okay, could actually work as long as you keep the same numbers. So when I say you're connecting C11 to A12, you could actually connect D11 to A12 or E11 to A12, because A, B, C, D, and E in any one column of the number is all connected. So that's just, if you want to follow along, just do what I did. But if for some reason you're having a tough time, any one of the columns going this way into the 5 would work. Okay, so one last resistor that we have here should be the last one, which is the last 10K resistor, which is going to be used as a pull-down resistor for our button, basically just to keep, we're going to be reading in a value from the button to our Arduino, and by having the 10K pull-down resistor, just basically keeps everything nice and stable, and there's no noise or anything floating around. Okay, so last thing we have to do here is A22 to the negative rail. So A22 to a close spot on the negative rail. Okay, A22 to the negative rail. And there we go. We got our components in place. We've got all the resistors we need in place. And the last thing we need to do then is concentrate on all the jumpers. Okay, of which, yes, there's 24 of them, so there's lots of connections that need to be made. But we'll just go through it again nice and slow, and we'll get everything built here. Okay, so first we're going to concentrate on the jumper connections to get the LCD working, of which there are 12 of them. Okay, so generally if it's a positive connection to the positive rail, I'll use a red wire, and if it's a negative connection to the negative rail or a ground, I will use a black wire. But it doesn't have to be any of these wires, right? It doesn't matter which ones you use, but that's generally what I'll be doing here. So first of all, I'm going to take a black wire, and I'm going to go from F16. So the F row is this row that you can see right here, the row that, or the row, pardon me, that's exposed just above all of the pins for the LCD. Okay, so the very end one down here is 16. The very top one up here is 1. So we're going to start at F16 and work our way back towards F1, making the proper connection. So we're going to go from F16, okay, to the negative rail. Now most of my connections are going to use the positive and negative rails. These positive negative rails, these ones down here for the LCDs, we only use the negative rail, so we have to make sure that we connect negative to negative rail at the end, which we'll do. But anyways, so F16 to the negative rail. So I'm just going to connect it down here to the negative rail. I'm going to take a red wire, and I'm then going to go from F15 to the positive rail. Next, we're going to take just any one of the colored wires here, and we are going to connect F14, so the next pin down. Okay, now this is the connection for our backlight, or pardon me, our contrast. So the contrast voltage divider was the second voltage divider circuit we did there. Now this is very important that you connect it to the column 10. So you can either connect it to D10 or E10. I'm just going to connect mine to D10. All right, so that's going to tie it into the voltage divider circuit for our contrast. Next, another just colored wire, and I'm going to go from F F12, or no, pardon me, F13, 16, 15, 14, 13, F13. The next one to our first Arduino connection, which is to digital pin 12. Okay, so all the digital pins are here, analog pins are here, and then power and ground pins primarily there. So again, we're going from F13 on the breadboard to digital pin 12 on the Arduino. So there's our first Arduino connection. Next, we're going to take, I'm going to take a black wire, and we're going from F12 once again to the negative rail. So I'm just going to pull this across over to a negative rail over here. Again, I certainly could have connected it over here to the negative rail. It does not matter. Next, another just colored wire, and we're going to go from F11, next one in order here on the LCD, to another Arduino connection at Arduino digital pin 11, which is right beside the one we just made. Okay, so we're moving along, getting there. It's getting a little cluttered, as we can see, but we're that much closer to playing Pong. So next, we skip 4. Okay, so connections F10 through F7 have no connections. And the next connection we're going to make is F6. Okay, so F6, and it's going to Arduino digital pin 5. Next, F5 to Arduino digital pin 4. So just moving down. The next two are the exact same. What I mean by that is we just go to the next LCD pin, which in this case is F4, and this is going to Arduino digital pin 3. One more to the Arduino anyways, which is F3, and now that is going to Arduino digital 2. Okay, so those are all of our connections between the Arduino and the LCD. There's two more that we need to make here, but these are, one's a negative and one's for the backlight. So next is F2. Okay, and this gets tied into our voltage divider circuit for our backlight. So what we need to connect it to is we need to connect it to C8. Now again, you could connect it to C8, D8, or E8. I'm just doing the closest one, closest empty hole, which is C8. Okay, so that's tying the voltage divider circuit in for the backlight, and then we'll have the proper brightness. And lastly, we need one more negative. So from F1, we want to connect this to the negative rail. So there's a nice convenient one just right here, and I'll connect it to the negative rail. Okay, so those are all the connections for the LCD. Next is we need two wires to connect the button. So I'm going to take a red wire, just because it's positive, it doesn't have to be red, and I'm going to connect A24, which is right here, A24 to the positive rail. So I'm just going to go over here to the next closest positive and plug it in. A24 to the positive rail. Next, I'm just going to take a colored wire and go from B22, and this is going to our Arduino. This is what's going to read if the button is pressed, and this is going into digital pin 9. Digital pin 9 on the Arduino. Okay, the next is to connect the potentiometer so it can read in the values, so it can adjust the paddle. Now to do this, we need positive and negative to go across the potentiometer. So I'm going to take a red wire first, and I'm going to connect A26 to the positive rail. So just any spot on the positive rail. Next, I'm going to take a black wire, and I'm going to connect A28 to the negative rail. So there we go. We got our positive and negative connections, or positive and ground connections going across our potentiometer. And now to read in the value, I'm just going to grab another colored wire and then go from A27, so in between the last two on the breadboard, A27. Now this is going to analog pin 0 on the Arduino because the potentiometer is an analog sensor, so it needs to go to an analog pin. So we're using A0 in this case. Okay, getting very close now. Just a couple last things. We're going to connect the speaker or the piezo element. So to do this, we're going to connect C18. Now it might be hard to see which column is 18 because our piezo is, or my piezo anyways, if you're doing it like me, is covering it. So I can see 20, I can see the column 20, so I'm going to count 2 back to get to 18. Okay, I'm going to go C18, or again I could use D18 or E18. So C18, and this is going to Arduino digital pin 10. Digital pin 10 on the Arduino, and that will provide the quote-unquote music for our game. So that's to connect the piezo, and then the last handful of things we have to do is to connect the LEDs and then just bring power from the Arduino over to the breadboard and hence all the components. So let's do the LEDs. So I'm just going to grab another colored wire and we're going to connect I25. So this gets a little tight. Again, you could use H25 if you wanted to, or G or F25. I just tried to push these wires as far this way as I could so I could get my hand in here to control the potentiometer and play the game. So I'm trying to leave as much room as I can kind of around this potentiometer. So anyways, I'm doing I25. So you need to kind of open up the resistors a little bit to get to I25. Going to digital pin 6 on the Arduino. Next, 2 more to connect. We're going to go from I27. This is where you have to open up the resistors to get kind of inside them. I27 to digital pin 7 on the Arduino. Alright, and last for the LEDs is we're going to I29 to digital pin 8. Now again, the pins are getting pretty tight there with all the jumpers on the Arduino, but just be careful not to bend or break anything there, but everything should fit. And there we go. We got a lot of connections made now. Things are getting pretty cluttered, but we're getting pretty close to being done. Then the very last things we have to do is, like I said, is just to connect power and ground. So I'm going to take my last red wire here, go to the 5-volt terminal on the Arduino, and all I have to do is connect it to the positive, this positive rail on this side. Okay, again, because the positive rail on the other side of my breadboard is not being used at all. There's no components being plugged into positive rail on this side. Okay, 2 more wires. So next is ground from the Arduino over to the negative rail. So again, any convenient spot, negative rail. So that's going to connect power to ground. And then the very last wire we have to connect is, because we're using this negative rail down here, we could connect it all the way back to the Arduino if we wanted to, or we could just go from negative rail to negative rail, and that's what I'm going to do here. Now what I've done is I connect it here, and then this one actually I bring the wire underneath the LCD and connect it to the negative rail just to kind of get it out of the way a bit. You certainly don't have to do that. And that's it, and everything should be connected. Now, so I already have the code loaded on the Arduino, so I'm just going to grab 9-volt power here and plug in my Arduino, and fingers crossed everything should be up and going. Okay, so the code is there, so we see press the button to start the game. So we press the button and grab our potentiometer, and the game starts. Alright, so I hope that helps you guys. Again, if you have any questions at all, please let us know. We're always here to help, and really enjoy helping you guys out. Thanks so much. Bye for now.